All right, so these ones are using the t substitution. So you want to kind of do over and over again, practice your t substitution. So you know if you let t equal tan x on 2, if we differentiate both sides, we've got to t equals, now tan goes to sec squared, and then we've got this half that we have to put out the front as well. Let me times both sides by 2 to get rid of this half over here. And the other thing we have is sec squared, remembering sec squared is the same as 1 plus tan squared. So, and the half angle, so that's just 1 plus t squared. So what I can do is divide 1 plus t squared, there we go. So my dx, and that should be a dx, so my dx is 2 to t on 1 plus t squared. All right, so that comes in handy all the time. So if you can do that, practice doing that quickly over and over again, because you're going to use that over and over again. All right, so the first one is 1 on 1 plus cos x. So our, do it over here. So I'm going to change straight away the dx. I'm going to put the dx on top. So dx is 2 on 1 plus t squared to t. And then we've got 1 plus, now cos x, in terms of t, we know is 1 minus t squared on 1 plus t squared. So what we can do actually, because there's so many fractions, you see all the fractions that we have 1 plus t squared on the bottom. So if I times by 1 plus t squared through the top and 1 plus t squared through the bottom, we can get rid of that. So at the top, I now end up with 2 to t. And at the bottom, that 1, if I times it by 1 plus t squared, becomes 1 plus t squared. And then I just have 1 minus t squared. Yeah. So if I simplify that a little bit, you can see at the bottom the t squareds will cancel. I'm just going to get a 2 on the bottom. So there's a 2 on top and bottom that are going to cancel. So really I'm just integrating 1 with respect to t, which we know is just t plus c. And t, remember, represents tan x on 2. The hard part is remembering to put it back in terms of x. Yeah, easy to forget. All right, so let's go to the next one and have a look. So for this one, we'll do the same thing. So again, for the dx, which is on top, I'm going to put 2 on 1 plus t squared to t. And then I've got 1 on the bottom, I've got sine t, which is 2t on 1 plus t squared, and cos t, which is 1 minus t squared on 1 plus t squared. Okay, so again, you can do it in your head as well, but what I'm doing is I'm timesing the top by 1 plus t squared, timesing the bottom by 1 plus t squared. So really I'm just timesing by 1, so I'm not changing anything. I'm going to put that 2 out the front. So you can see I'm just going to have the t on top, on the bottom, timesing the 1 by 1 plus t squared, and then getting rid of the denominator of the next one, getting rid of the denominator of the next one. Just be careful, it's minus 1 minus t squared, so it becomes minus 1 plus t squared. So you can see that simplifies to a kind of a nice denominator. We've got 2t squared plus 2t. Now if I factorize by 2 and pull that 2 out, it will cancel with the 2 in front because I have 2 over 2. So really I've just got to t on t squared plus t, or t lots of t plus 1s. So I can use partial fractions to do this. Now you know that, so I'll do it over here, 1 on t plus 1. If you want, you can put a on t and then b on t plus 1. So if you use the cover-up method and cover up t and sub 0 in, you will find that a equals 1. If you use the cover-up method and cover up t plus 1, so you're subbing in negative 1, you can see you'll get b equals negative 1. So the integral we're actually using is 1 on t to t, take away 1 on t plus 1 to t. So this is the integral. We're actually breaking it up to using partial fractions. And so this will be log t minus log of t plus 1 plus c. Or another way of saying that is log t on t plus 1 plus c. And another way of saying that now, so in terms of x's, remember t equals tan x on 2, so that's going to equal log of tan x on 2 and 1 plus tan x on 2 on the bottom, plus c, of course. Okay, so just remembering to put it back in terms of x. All right, so looking at this last one, just have to rub this out. Okay, so, oops, where did we go? Here we go. So again, the last one, I'm going to sub in our 2 on 1 plus t squared dt on top. So that's my dx, and on the bottom I've got 3 lots of sine, so that's 2t on 1 plus t squared, and 4 lots of cos, which is 1 minus t squared on 1 plus t squared. So if you want to do a bit of, you could always do a bit of simplifying on the side as well, if it gets a bit too much. So again here, if I'm going to put the 2 out the front and put t here, so I'm going to multiply both top and bottom by that 1 plus t squared, so it gets rid of that, it gets rid of that, and it gets rid of that. So you can see you're going to have 6t plus a 4 minus a 4t squared at the bottom. Now, that's all divisible by 2, so I can pull a 2 out and it'll cancel with the 2 that's already there because it'll be on 2. And the other thing I'm going to pull out is a negative because it's a negative t squared, which I don't particularly like. So I'm going to make it a 2t squared, a minus 3t, and a negative 2. All right, and we know that we can actually factorize that, and we'll get 2t plus 1, 2t squared, and let's see, that will be minus 4t plus t is minus 3t and negative 2. Yep, that works. So we can use partial fractions again. So again, if I just have a look to the side and have a look at that as a partial fraction, t minus 2. So I'm going to put an a on the 2t plus 1 and a b on the t minus 2. Sorry about my writing. All right, so if we do the cover up, if we cover up 2t plus 1 to find a and sub in negative a half, so we're going to have 1 on negative 2.5, which is negative 2/5. If I, turn it upside down. And cover up method for b, so I'm going to cover up t minus 2 and sub 2 in, so 1 on 5. There we go. So now I can go back and use partial fractions. So I'm going to have for t, yep, all right, so for a, so I'm going to integrate, I need the 2, so I'm going to put the 2/5 here, and I'm going to put, I've got minus, haven't I? Oh, I've already got a minus, so let me just go again so you can see what I'm doing here. So here's my integral, so I've got minus, and then I've got negative 2/5, so I'm going to go positive 2/5. And I've got 2t plus 1 here. And again, I've got minus, and here b is a 5th to t on t minus 2. So you can see here the derivative of 2t plus 1 is 2, and that's on the top. So I'm just going to get 1/5 log of 2t plus 1. Oops. And here I'm going to get minus. So again, the derivative of t minus 2 is 1, so that's fine. Log of t minus 2. If we put that together, they've both got 1/5, so I might do 1/5 log of 2t plus 1 on t minus 2. It could be 2 minus t, it would be the same there. So changing back to x's, two lots of t's, so two lots of tan x on 2's and one lot of tan x on 2. Minus 2 there. It could have been 2 minus tan x on 2 as well. It's absolute valued. All right, hope that helps.